everybody. My name is David Czarnecki, and thanks for sticking around here for the last session at Ruby Midwest. I think by virtue of the title of my talk, I was probably destined to have the last slot here. So if I ever reprise this talk, I'm going to have to certainly change the title so I can go up first. I'm going to be talking about Ruby and Rails and how we use that in the game industry and some of the challenges that we faced in making that work well. Before I get started, we've thanked all the presenters for coming up here, but I'd really like to, if we could all give a round of applause to the organizers on the side. Really putting together a great conference. You can find me on Twitter at Czarnecki if you're interested in video games or Ruby. I take pictures of a lot of food. Sometimes I Twitter about beekeeping. If you're interested in those things, then follow me, but don't be obliged because I'm up here talking words at you. I work for a company called Allure Games. We are in upstate New York, basically 2.5 hours direct north of New York City. We got our start developing community sites for video games, whether it be a handheld DS title like Transformers or Transformers 2, all the way up to console titles on the Xbox and PS3. And we also have a middleware product that we develop that game companies can integrate into their games to pull data out of games. We do interesting stuff with it, and then we can feed that back to the game. We can feed that back to a community site, to the web, to a mobile device. Right now, our middleware platform is Python-based, but really the ideas and genesis in the work came out of all the Ruby and Rails that we were doing and still continues to this day for certain titles. So we've worked with titles you may have heard of, Call of Duty, World at War. This year we worked on Brink, Mortal Kombat, Batman Arkham City. So you've got the Batman sticker on your laptop. And we've been involved with the entire Guitar Hero franchise since the beginning. So again, many of the ideas that I'm going to talk about are kind of born out of what we had to do to scale Ruby, to scale Rails, the services that we have, and scale our infrastructure. Unfortunately, this isn't one of the titles that we work on, but I'd really, at some point, like to get in contact with the folks at Cabela to work on the Safari series, and not just because it's the meme of the Ruby Midwest conference. We're also a part of Major League Gaming. If you are into competitive gaming, competitive StarCraft, competitive Halo 3, Halo Reach, then you may know MLG as the MLB or NHL or NFL of esports. And we handle all the development for their online properties like MLG TV, game battles where you can go online and compete against other gamers, and all their live events. Just to give you an idea of some of the data that we're handling and that's going through our network, 60 million plus players across the different titles that we work with. In 2011, 1.3 petabytes of data, and we'll probably be somewhere close to, I think, 2 by the end of the year as numbers go. Kind of an interesting little Twitter bite here. We talks directly to our Rails stack for all of the Guitar Hero titles less than Guitar Hero 5. So Guitar Hero 3, Guitar Hero Van Halen. If you're playing on the Wii, you are talking when you finish a song or when you want to get the game code to link your account in your game to the community site. All that's talking directly to our Rails infrastructure. So kind of awesome, right? I mean, we get to write Rails and then in some small way really shape the way the online experience happens for a major title and a major console. So one of the problems that we ran up against was scaling Rails. And I think the approach that I took in this talk, which was quite a bit different from maybe a similar talk that I had given 2 years ago at RailsConf, was to talk about a few problem areas and really talk about our approach of how we went about working with different services or working with large amounts of data. And hopefully you'll be able to extrapolate the ideas that are presented in the talk and use those to come up with solutions or approaches for your applications. Because quite honestly, every application, every code base is different, so the needs that you're going to have in terms of scaling are not necessarily going to be the same that we have. So let's tackle the easy stuff, right? You should Google right now, if the internet is working for you, Google for Ola Bini just add scaling. So it was a really great blog post a couple of years ago that he wrote about the fact that scaling isn't present in any language. So you can't look at bytecode for Java or what gets generated in the Ruby standard libraries. There's not a module that you can add, so I'm going to add the scaling module, and all of a sudden my Ruby's magically going to work faster, better, harder, stronger. It's just not a thing, so we have to be smarter about how we approach scaling. For us in the video game industry, it'd probably be okay if we could cancel all of the major holidays, if kids were in school every day of the year, if we didn't launch titles at all. But quite honestly, that's not the case. People never stop playing video games. Data is always coming in. So just to kind of drive home the point of Christmas being canceled, here is a quote from our CEO. After Guitar Hero 3's launch and the associated influx of data that was burying us, I remember telling a random person that had just bought Guitar Hero 3 at GameStop not to go online. You cannot do that, okay? That is not within the realm of possibilities. People are going to play a game. People are going to want to use your site. So I think the point that I want to drive home with this slide is when your company may go under, when your product is not having a successful launch, you are going to find the solution to scaling your systems that works for you. And guess what? That's fine, because you haven't necessarily done it the wrong way. Again, hopefully with some of what I'm going to talk about here, you'll be able to take the approaches and apply those to your challenges. So I'll talk a little bit about process, not too much, because I don't want to inundate you with that. So the problem is we need some process for how we go about developing our software. And it's nice if you can actually start with nothing and then build up to add in the processes that work for your organization, whether it be stand-ups or how you do flow in development, like GitHub flow, whatever it is. These are just a few that I've picked out that have kind of worked for our team. So I like to do things early. When I deploy, I like to deploy early in the day. I like to deploy early in the week. When we were launching Guitar Hero Aerosmith and when we launched Guitar Hero World Tour, Activision wanted to do midnight launches on the weekend. That sucks. because you're up all day kind of getting ready for the launch, and then you have to launch. It happens at midnight, you click the button, you deploy, make sure all your servers are in order, and then you're up for another 2 or 3 hours fixing whatever issues may have come up from actually launching. So if you can, it's nice to be able to launch early so that you can fix bugs or make whatever changes you need to make with a clear head. I can't stress enough that documentation always is key to any large project. Guitar Hero, as a Rails application, is a single application that handles all of the Guitar Hero titles. And starting with Guitar Hero Metallica, I really made a concerted effort to codify that into a document. So it lives in our version control, and it's called Creating a New Guitar Hero Title.txt. And it's about 13 or 14 steps of all the things that you need to do to the code base to bring in a new Guitar Hero title. So it was great because for Guitar Hero Greatest Hits, for Van Halen, for Band Hero, and for Guitar Hero 5, I just followed the steps in that document. And usually what it was I got an Excel spreadsheet from the developer of the game, sometimes Activision itself, to say, hey, these are the 96 songs that are going to be in Guitar Hero 5. Did a little munging of the data, get it into our configuration files, and usually by the end of the day, I had the title ready on staging to be able to play one of the builds of the game and be able to see stats being collected from the game. And so anybody in the organization could use that document and basically do what I did. For us, a lot of what we were doing with community sites, and I guess the web in general, is that web applications are never done, right? A new browser comes out, there may be incompatibilities with the latest release of Firefox, so you're constantly making changes to your software, and it's easier for us as a middleware provider or as web developers to make those changes. It's very costly for games to do title updates. There's actually a bit of code in the Guitar Hero application for Guitar Hero World Tour. We interface with a third party for doing leaderboards on the PS3 and the 360. And the identifier in the database for pulling out the song for Living on a Prayer is different from the song identifier that we get from the game. So we have to kind of do a little data munging in the application to actually make that work. And it's cheap for us because it's a couple of lines to change the identifier around. That would probably cost tens of thousands of dollars for a game developer to go through QA, go through recertification, push out the patch to the world and make that available. So as web developers, we can be more smart and have to fix problems for other folks. I definitely find that employing overhead, this is our VP of production, and they provide just a valid role as developers do in the organization, just as designers do in the organization, and that they are managing the client. I could spend part of my day working with the client, kind of interacting with them, but that's their forte, that's their expertise, and so having them around is just as valuable as the work that I do. Talk a little bit about game integration. We get a lot of data all of the time, as you can as you may have seen from the numbers that I displayed before. So how do we process that data? Because we have to process it all the time. In 2008, when Guitar Hero World Tour launched in the fall, most people didn't end up buying the game or waited to buy the game until Christmas because it was like a $200 bundle to actually buy it. So on Christmas Day, our systems crashed and burned because of the way that we were handling data. And I remember driving back from my parents. I headed back home a couple hours north upstate, and got back, saw that the systems were basically not doing anything, and spent the entire night getting to a nominal state so that we could move forward. And that wasn't fun. So we had to re-engineer our approach for starting with Guitar Hero Metallica to take what we were doing in this weird threading and forking and collecting threads and sending them to the application server and doing this weird data processing. So we got smart, and it's like 2009, and there are things like queues that we can use to basically shunt all the data processing and actually have a pipeline for the different games to be able to take data from the game and have workers that will churn through that all the time. Guitar Hero has been running with Sparrow. It's an old queuing system that uses Memcache. We built a simple controller that allows us to monitor the events. You're probably using Rescue right now to do job processing. We use that now as well. We got smarter because it's awesome. But why is it awesome? Rescue Web. You have a view into what is happening in your system. And the more you can monitor and measure things in your system, the better you are to be able to handle and know what you're going to need to optimize for. So what do we optimize around? We have to optimize around school vacations, so the summer. Obviously, Christmas, obviously we can't cancel those holidays, so we need to do what we can to be as performant during those times when we're going to see more data. I'd like to think that all queues are equal, but really they're not. What we found is that when a new game comes out, people are always playing the new hotness. So we will throw more processing power when a game launches to process all the data for the latest title, because people are not going to be playing the older games. One big problem that we have is leaderboards. I remember interviewing and getting asked, how would you implement leaderboards? And so one approach that we used for quite a while was MySQL, and that will take you so far if you have a few thousand scores that you need to collect. But obviously for all the titles, for a game like Guitar Hero, we have 7 different titles or 8 different titles, I think it is, and then every single song in the game, and then for games that have the separate instruments, you got to keep all those. So it's just a morass of data, and like what's happening in the picture there, the MySQL leaderboard code that we have, to look at it, I just want to shoot myself in the head because it's so convoluted. So short interlude, it was this past year on New Year's. I went out to dinner and decided to take a cab. And when I got done with dinner after midnight, called the cab company and tried to get a cab on New Year's. Like, not going to happen. So they said, call the free ride. So free ride was like, yeah, we'll take you back home, that's fine. And I ended up riding the short bus back home on New Year's. And I woke up and I was like, it's 2011 now, and we don't have flying cars, and I just rode the short bus home from dinner, so I'm going to make something awesome for the universe. So Leaderboard is using Redis sorted sets to do leaderboards, and we've kind of migrated our infrastructure to use that. Those two images were from Cobra, probably the greatest Stallone movie ever made. I mean, we can argue that after at bowling, but it really is. So, external services. Problem is, we need to integrate with third-party data services. So, how do we do that well? And how do we do that internally? So, we can use brute force. We can force ourselves to be performant. So we cap our unicorn requests at 30 seconds. 30 seconds is a long time for requests to be happening in your application. So if a request is going to take more than 30 seconds, find a way to get that data back to the client, back to the web in an asynchronous fashion. Because you're just going to kill yourself and you're not going to have ever enough processing power if you just let requests run on and on without imposing some limits on their execution. Timeouts. Beginning of this year, we launched a site for MLG called MyMLG. It was basically like Facebook, but for MLG, where you could go and give your status. We would post status from game battles. Hey, this person just won a match. So when we launched, I couldn't keep the site up for more than a second or two, or at all. And it turns out game battles that we talked to actually render some of the information on the page was being DDoSed. And so when I went and talked to one of our production folks at about 4 in the afternoon, he's like, oh, game battles is being DDoSed. Oh, I would have liked to have known that at 9 a.m. as the site was crashing and burning. So if you can, impose the constraints on actually talking to services. So I think the default when you are using like NetHTTP to talk to a service is like 60 seconds, way too much time. Start with something like 10 seconds and slowly ramp back and see, what you need to do to not kill your systems. Obviously, caching data. We cache queries, cache view snippets. It's really easy to do. Monitoring and infrastructure, I probably can't stress enough that you do need some way of looking at the overall health of your system. So, I won't be talking about, well, I don't know. Here's just a few approaches that we use. We started with Munin, and our systems folks have kind of gravitated towards using Runit. And so it's just another tool that can monitor a process, look for it being errant in terms of memory usage or it not being started and actually start it up for you. It's great to have graphs of the state of your system. So we use Munin, and it has a lot of great plugins, or just out of the box will monitor a lot of things about your system. And you'll have different thresholds for seeing kind of where the state of your system should be. And maybe after you deploy, you take a look at the Munin graphs and go, oh, for some reason our processes or our forks are spiking. Why is that? We should investigate that. We also do infrastructure validation, and it was an interesting exercise that one of our systems guys did. He actually wrote a whole set of infrastructure validations using Cucumber. So it will check for things like, is MySQL running? Is MySQL slave running? How far behind is your MySQL slave? 5 minutes is probably okay, but if it gets to an hour behind, somebody should probably check as to why the slave is behind. Is Memcache running? And so, however you want to do that, it's nice to be able to know what's going on and continuously run those validations to know that everything's are operating normally. We had this bite us in the ass Tuesday of this week. So the machine that we have running Redis, Memcache, and our mail server shit the bed. And all of our applications, instead of using a name service like Redis.internal, whatever, we were exposing the machine name directly. So moving to a name services approach where you have internal DNS names to point to those services just helps us now in that if a machine goes down, we can retarget the service to another machine. And then anything worth doing once is probably worth doing a second time. So when they built the Death Star, they didn't build one, they built two. So if you have the ability to have a backup infrastructure, that is great. Let's see. Does anybody follow StarCraft 2 and kind of the Barcraft? Okay, so not many people here had a little treat for the Ruby Midwest folks. So we've got MLG Providence, which is our pro circuit event that we run throughout the year, and the big finals are coming up in 2 weeks, middle of November. So the first 25 ats with that, I will give you an HD code to watch the streams for free. You can watch competitive StarCraft, competitive Halo. It's actually really interesting. I didn't think that it was going to be that compelling, but it's just fascinating that these guys make a living playing video games. And I think, how much more time do I have for questions? So 2 minutes for questions, but thank you very much, and happy Ruby Midwest. Questions?
Sizing-wise, you talked about storage and how many players. How many simultaneous hits do you get on a peak?
How many simultaneous hits do we get at peak? Let's see. For the middleware platform now, I think we can handle 8,000 or 9,000 requests a second. So far, we probably have capacity that would far exceed any kind of launch, even for an upcoming launch like Modern Warfare 3, I think we have enough capacity to do that. Probably on average we have maybe, 200 to 500 requests a second internally that we're processing for game data.
You talked a lot about failures that let you learn.
Mm-hmm.
How did you, maybe it's just a misperception, but it seems like there are a lot of failures, and you are working with other companies. How do you handle that? And was that just not a very big part of the big picture? Like, we're just hearing about the bad stuff, but there's lots of other good stuff.
I guess, okay, so the question is, I talked about a lot of failures. I I guess to go back to what Joe had talked about earlier is that I always have a positive spin on what we can learn from those. So, we failed initially in we didn't have enough capacity to handle the data. And then we learned from that to, not have crazy town to actually process all the game data, and we got smart about how we could do that in like a queued fashion. So
do you just have a good relationship with the people? That's when we look at other companies, is that?
Oh, yeah, we definitely have a good relationship. I mean, if we're not successful, then they're not successful. So they understood by virtue of sending folks out for 2 weeks to kind of oversee, like, are you doing the right thing? Yes, we're doing the right thing. But, over time, we got to the point where it wasn't an issue in terms of handling the data or doing the integration. They trusted us at that point after, the initial hiccups. Anybody else?
Can you speak to your hardware capacity and structure, how many machines it's all running on?
Yeah, I can talk about really quickly for the past month. As far as the MLG side of things, I was just doing a stack smashing. So we have all these VMs running at rack space, probably over 100, and I took that down to 2 physical boxes. So physical hardware is great if you have the money to throw at that, and we have the money to throw at that problem. So physical boxes are awesome. I think it's 2 24-core machines, huge gigs of memory and space. So we know our I/O is going to be set. We don't have to worry about kind of I/O contention and things like that. I guess we still do if an application is errant, but for the most part, that's kind of a non-issue for us.
All right, I think that's it for the questions.
Okay.
Thank you very much, David.